In this video, I'm going to elaborate more on sin x over x. We've already seen this and we've already proved this, so I'm expecting you to accept this. But in this video, I'm going to illustrate to you that even if you have x squared and x squared, as x tends to 0, if this bubble heads towards 0 and this bubble heads towards 0 and they're on par with each other, then you can conclude that this whole thing here equals 1. Even if you have x to the power 3, x to the power 3, as x tends to 0, you can see that this bubble and this bubble head towards 0, and they're heading towards 0 at the same rate. So you can conclude that it equals 1. But suppose you have, let's say, x to the power 4, and then this is 3, and then this is 2x to the power 4. As x heads towards 0, even though this bubble heads towards 0, even though this bubble heads towards 0, they're not on par with each other. They're not heading towards 0 at the same rate. So we can't conclude it equals 1. We just can't conclude that. Remember, from our proof, these two have to head towards 0 at the same rate. They must head towards 0 at the same rate. You see here, this one here heads towards 0 a lot faster than this one here, so we can't conclude here. Let me illustrate why this is the case. Hang on. So we can accept that this equals 0, this equals 1, because we've already proved it. When x equals 0.9, sin x over x will become this, squared will then become this, to the power 3 will then becomes this. When x equals 0.6, sin x over x would become this, squared will become this, to the power 3 becomes this. So you can see that that as x tends towards 0, this is a mistake here. Hang on, let me fix this. As x tends to 0, hang on. As x tends to 0, you can see that this bubble and this bubble, they're both heading towards 0. Hang on, they're both heading towards 0. Well, if you look at this and this, they're both heading towards 0. So these bubbles are getting smaller and smaller. These bubbles are getting smaller and smaller. These bubbles are getting smaller and smaller. Even in the case of x squared, these bubbles are heading towards 0. They're getting smaller and smaller and smaller. They're getting smaller and smaller and smaller all the way down here. Even to the power of 3, these bubbles are heading towards 0. They're getting smaller and smaller and smaller. They're getting smaller and smaller. So going back to here, even though you've got x squared and x squared, the whole, as x tends to 0, the whole problem here really renders to this problem, because if you look at it collectively as two bubbles, these two bubbles are heading towards 0. Even though it's x squared, these two bubbles are heading towards 0, and they're on par with each other, meaning that they're heading towards 0 at the same rate, just like over here. Now over here you've got to the power 3. Even those to the power 3, this whole thing here renders to this problem where you've got two bubbles heading towards 0, and they're both heading towards 0 at the same rate. So you can conclude that that the limit of this equals 1. You can conclude that the limit of this equals 1, because this problem renders to this problem, and this problem renders to this problem. So let me give you some more examples. Hang on. So whenever these two bubbles head towards 0 at the same rate, then you can conclude that this whole thing here equals 1. So so you can see that sin x over x, the limit is 1. X squared, the limit is still 1. To the power 3, the limit is still 1. Let me give you some more examples. So here you can see that these two bubbles are heading towards 0 at the same rate. So you can conclude that this equals 1. Yes, you can. This one here, if you look at, hang on, if you look at this bubble and this bubble, even though these, as x heads towards 0, you can see that the top bubble heads towards 0. You can see the bottom bubble heads towards 0. But they're not heading towards 0 on par with each other. So we can't conclude that this equals 1. It might not, but we just can't conclude it equals 1. So here, don't assume this equals 1. Because when we proved sin x over x, lim as x tends to 0, we proved it by making sure that these two are heading towards 0 at the same rate. This one here, they're not heading towards the same rate, so we can't conclude that. Don't conclude that. So for this one here, even though these two bubbles are heading towards 0, this one here heads towards 0 faster than this one, so we can't conclude that this equals 1. We just can't conclude. Okay, this one here, do these two bubbles head towards 0 as x heads towards 0? The answer is yes. They both head towards 0. And the thing is, they both head towards 0 at the same rate, meaning they're both on par with each other, meaning they're both the same. So here we can conclude it equals 1. Yes, we can. Okay, so next one here. As x heads towards 0, are these two bubbles heading towards 0? The answer is, as x tends to 0, this bubble here heads towards 3. This bubble here heads towards 3. So we can't conclude it equals 1. You see, here the limit is actually quite easy, because if you put 0 into here, it will be sine 3 over 3. So here the limit is this thing here, because you're not actually dividing by 0. Nothing really breaks down. So the limit here is actually very easy. The limit is sine 3 over 3. Nothing breaks down. You're not dividing by 0. Okay, so next one here. Let's say as x heads towards 0. So what is the limit of this as x heads towards 0? So you've got to check, are these two bubbles heading towards 0? The answer is no, because when you put 0 into here, it would be sine of negative 2, and then put 0 into here, it would be it would be negative 2 at the bottom here. So here the limit is actually this. The limit is sine negative 2 over negative 2, because nothing breaks down. You're not dividing by 0. So here the limit exists, and it's this limit here. But suppose I were to change it so that x heads towards 2. So as x heads towards 2, when you put this into here, it would be sine of 0 over, put 2 into here, would be 0. Now here you've got a case where 0 over 0. But the thing is, we've proved that even though these two, we've proved that when this bubble heads towards 0, this heads towards 0, the limit is 1. So here, these two are heading towards 0, and they're on par with each other. So as x heads towards 2, we can conclude that the limit is actually 1, even though even though we're dividing by 0. But we spent a lot of time proving that sin x over x equals 1. So here I know hang on, here I know that that it breaks down because you're dividing by 0, but we spent a lot of time proving that the limit of this thing here is 1. So here, when x heads towards 2, we can say the limit is 1. When x heads towards 0, the limit is actually sine negative 2 over negative 2. Okay, so for this one here, check, do these two bubbles head towards 0? In this case, they do head towards 0, but they're not on par with each other, so we can't conclude that this equals 1. We just can't. So for this one here, check, do these two bubbles head towards 0? And the answer is yes. As x heads towards 0, this bubble will head towards 0, and this bubble heads towards 0, and they're on par with each other, so we can conclude that this equals 1. Okay.